Okay, so once again, welcome to Coding Collecting Data with the Greenhouse Sensor Control Kit. I'm happy to share the Greenhouse Kit with you, in addition to some coding tips using Blockly in Pasco software, and just showing the equipment. I'm going to switch my camera real quick so you can see that greenhouse right now. And this is the kit we'll be going over today. Let me move this out of the way. So what are we covering today? We will be talking about the Greenhouse Sense and Control Kit itself and the resources it comes with. I'll be going over some basics of how to use Blockly and navigating through the different types of blocks, a little bit of coding. We'll be starting with just some simple code, and I'll be ramping it up to a little bit of advance towards the end of the presentation, and how to work with the inputs and outputs in Blockly. So there are several options for inputs and outputs. Oops, there we go, in the greenhouse. So for example, what you're looking at right now, this is the greenhouse system. You are looking at the light on the top, this metal piece that looks like it's glowing. That is a grow light that has red and blue, or sorry, red and green, keep saying the wrong word, red and blue lights. And that is one of the outputs that you can control with the system. You can also control the water pump. So right here you see a water reservoir. It's just a water pitcher. The water pitcher itself is not actually part of the kit, but the pump is, and it looks a little bit distorted because I've got water in my water reservoir there. So a water pump comes with the system. There's also a fan output. Here's the fan. And this blurry piece, it looks like a, I don't know, just a white spot right here. This is actually a feather so that you can see them when the fan turns off and on, as I demonstrate code and some programming to turn that that fan off and on. So we can code these outputs, the water pump, the light, and the fan, to respond to different environmental factors. For example, the soil moisture, and inside, I'm going to turn off this light briefly so maybe you can see better inside of the kit. So in the kit, right now I've got a plastic plant. This is not a real plant. It's a plastic plant, and I put it in a cup rather than a pot so that you could see through and notice that there's some water in that cup. So normally you would have a potted plant in here, but just for sake of being able to see inside, that is plastic. So you can also see that red vertical piece there, that is a soil moisture probe. And we can use this soil moisture sensor to read the soil moisture level of that potted plant and control the pump to automatically water the plant. You can also see that there are, it may be hard to see, but there's a dripper system. Let me switch the camera so you can see maybe a little bit closer. There we go. So here is a dripper system that is hooked up with the blue tubing to that water reservoir. So we can control the amount of water going to the potted plant with feedback from the soil moisture sensor. We can control the brightness that the light receives with a kind of hard to see, but I'm going to point it out here at the top. There's a green rectangle right here underneath the lid. It's actually, it looks like it is a circuit board. And there's actually a light sensor on top of that circuit board that can determine the brightness level of the light, not only the ambient light, but also the light coming from the grow light output. Let me turn that back on so that it's ready to use. Okay, the fan. So we can also monitor the temperature and humidity inside of the system. On the other side of the circuit board, opposite underneath, there's a temperature and a humidity sensor. And if it gets too hot in there, which might happen because this is a closed system when we're adding energy from the light, we may need to regulate the temperature of the system. And real greenhouses have the same issue. The large scale greenhouses have that problem of needing to ventilate. So we can turn on the fan based on the temperature or the humidity to help regulate and move air inside of this closed system. Okay, so we've got sensor inputs, we've got temperature, light, humidity, and soil moisture, and we've got outputs, a fan, a light, and a pump, all controlled with the Pasco control node. So what you're looking at here, hooked up to the wires, this port right here is connected to the greenhouse sensor. This is where we receive the information from the inputs, the sensors for soil moisture, light, humidity, and temperature. are put into the control node, sent via Bluetooth to software, which I'll show you in a moment. And then we can control the outputs for the light through this channel here, channel A. And I'll talk a little bit more about channel B, this power output later. This is where we control the pump and fan. So that's just a quick overview, and I'll be going over each of these systems individually today. So the other thing that comes with the system is some 5 digital investigations. So these are more, if you're really you're not sure where to begin with coding, I would recommend doing the 5 digital activities that walk you through from basic all the way to advanced, and I'll be showing you where to get those later on in the presentation. I'll share ways to share code with others, either for learning or because sometimes, I mean, that is something that we do when we are trying to learn, or when we're working together, you know, we will often share bits of code with one another, and there's ways to do that, a number of ways to do that in the software. There's also the ability for the control node to, on its own, control the greenhouse without even being connected to any software, and I'll go over that. And finally, more on where you can find more support and some tips for being successful with coding with Blockly. Even if you don't know anything about coding, you can start from the beginning and work your way up to advanced using Blockly code in our system here. Okay, let me scoot this over. All right, let's preview and see what can we do. What does it look like when we program all of those things I talked about, all those inputs and outputs? Here are things I want you to look for in the video. We're looking for artificial sunlight, artificial rain, and artificial wind because, well, we've got this closed system here. We want to generate, we want to kind of replicate what nature does, which is take sunlight and water, and a plant can take these things with the help of wind and, you know, mixing up gases in the atmosphere. We can do some photosynthesis and a plant can grow. And we can cycle some carbon, we can cycle energy inside this closed system. So if you're looking at this closed system, check out the water reservoir, look at what happens with these inputs and outputs when I run some demonstration code. So I'm going to enlarge this so you can see. Okay, and I'm going to bring, first thing as I'm just going to run the code. Oops, let me, there we go. So I'm going to run the code in SparkView. And what I have to do first though, is I have to connect the control node to the software. So sorry, this is in the way, I'm trying to move it. There we go. What we're looking at here is SparkView, and this software SparkView has the Blockly program written in it. You might be used to seeing Pasco products like the carbon dioxide sensor or temperature sensor. You may have seen this before. If not, don't worry, I will walk you through where does it come from, how do you get it, and do you have to pay for it, and questions like that. So first, let's just look at the control node connection process. So here's the power. I'm going to turn it on, and notice that the light just shut off as soon as I turned on that control node. That's because once this turns on, it's already starting to control the power to the light through channel A. Okay, so I'm going to connect the control node to SparkView software. I'm going to go to the Bluetooth icon up here. And I see the control node is available here. So if I just tap it, it will connect. And get a better view of what's going on there. And I'm connected. I've preloaded some code. So I'm first going to start the code running. And I'm going to make this bigger so you can see what's going on inside the system. I will show you. Let me move this out of the way again. So let's look in the system. What's going on? We see the light is on. We see some messages over here and some numbers are changing. What are we looking at? Well, we are reading the percent water volume content. It's 21% right now. It's pretty wet in there. That sensor normally is in soil, so 21% would be high if this was soil, but it's in pure water, so it's a bit high. Now, there's these little text messages here and that little emoji. Cool, right? Cooling in progress. So these are status alerts about what's going on in the system. So it's kind of cycling through some things just to show you what it can do. It's saying it's watering the plants. Is it really? That means we should see water coming out whenever it says watering plants. It says it's reducing light levels. See how darker it's getting. Next, it's still reducing light level. So let's wait for the next message and see what it says. Increasing light level. So we should see the light go up. Yep, there it is. Says system is stable, but now it's saying it's cooling. Well, that means the fan should turn on. There's a feather moving. You can see that the fan is on and that it turned off, and now it says the system is stable. You might be able to hear the beeping from the control node. There's an audio alert coming out of this control node. There's actually sound coming out of it. That's part of the program. So that's to alert you what's happening with light and water. And let's zoom in for the next time we see the water come on. Now I'm going to switch angles again so you can look closely here at the dripper head. Next time it says watering plants. So the fan's running right now, just waiting for that dripper head to open up when it says watering in progress. There it goes. Do you see how it drips a little bit real slow, but then it stops? And that's the way you want to water plants with the dripper system. I'm going to hit stop right now so that you can see a little bit better. So we want the water to come out really slowly. We want to stop it and give it a chance to catch up because the soil moisture sensor needs time for that water to percolate down and renew the reading so you don't accidentally flood your chamber. You definitely want to get the water time to percolate down and give that sensor a chance to read. Now let's look at what happened with the data while the whole time we were running. Look at this graph. This graph is the temperature readings that were from that circuit board that I pointed out earlier at the top. So it got a little bit cooler in there actually, and that's because the fan was running at certain points. Also, we were adding some water in there. So if we look at the brightness level, remember it kept cycling through getting darker, and then getting bright again, getting darker. And you can see the cyclic pattern. We can definitely see that this is on a timer. So sleep functions or time functions are part of the program. Okay, so we can control how often something happens, which things happen when. We can base those changes on the data that's coming from the sensors. And all of that is built into this SparkView program. And by the way, if you know Capstone, it's also in Capstone. Through this little button down here on the bottom right, the code tool. Okay, so I'm going to give you a brief look at the code. And let me make it to the middle. This is the code that runs that whole program. Now it's deceivingly looking like only a little bit. Let me make it a little bit bigger. But what I've got in here, I've got a few things in here, and we're not going to start right away with loops and functions, but that's what we're looking at: loops, functions, and sleep or pauses in the code, time for something to run and then catch up with the sensors. So let's back up a little bit now. How did we get here? How did we get to this code and what's going on the screen? Let me go back to the presentation. So you saw a preview of what the greenhouse can do. What does code look like? Well, here were the parts that you saw. Here they are individually. There's that light. It comes with all the power supply that you need, and it comes with the cables. Everything that you see except for the water reservoir comes with the system. There's the water pump right there. It was a little bit distorted when you saw it inside the reservoir. The fan, here's the fan with the USB cable. The control node, which we use to send power out to the outputs and also to get sensor information back into the software. The sensor that we used right now was called the greenhouse sensor. That's what was able to read temperature, light, humidity, as well as soil moisture. I ran out of room and didn't put it here, but also read the soil moisture. There's also on the control node, let me switch to the camera real quick. So the control node has some built-in sensors that you might notice as we're working. It has a built-in accelerometer, and it also has some built-in outputs. It has a speaker. You may have heard that speaker going off as the alerts were going while the system was running. You can program the speaker on the control node to make certain sounds in your program too. Let me move this back. Okay. Some other stuff that comes in the system, this chamber comes with it as well. And you notice, the chamber here, there's holes in it to begin with, but all those holes can stay open or they can be occupied by different pieces of the system, and it can become a closed system if that's what you want to do. if you want to look at all of the measurements and the responses of the system in that closed system. Also some cable ties to stay organized, because you might have noticed there's a few cords and it just helps to keep things organized if you have those. So today we're talking only about the greenhouse kit, but I did want to point you to Passco.com. We won our sense of control kits, including the greenhouse. We won the Educators Pick Best of STEM award in engineering this year. So do check out the other kits that we have. The Passco bot. Hey, do you want to see what it takes to get the Passco bot to learn about object avoidance on Mars? That's one of the activities in the Passco bot sense and control kit. And it's similar to the greenhouse kit, where it comes with the sensors and the control node, and you can program inputs and outputs. Also, do you want to learn how to program a rubber band launcher or engineer a rubber band launcher with the control node sense and control kit? Again, it's learning to code inputs and outputs, in this case with a servo motor. So check those out. Going back to the greenhouse, look at all these questions. I just started typing questions that I thought of off the fly, of what kind of questions can I answer with this kit. And you can see in the picture is a real plant with a real pot and with real soil, the soil moisture sensor in there. So this is normally at my desk like this, and this is my desk plant. So what you can do with this kit, besides coding all those inputs and outputs, you can answer these questions. You can apply scientific principles to design and build systems. You can build structures. You can answer questions, or answer these questions, or design programs that help to solve the problems that this system creates. What I mean by problems that the system creates, well, these are all an artificial environment. You get trapped air in here, it gets too hot. How do we fix that problem? What if it's not wet enough in there? How do we fix that problem? What if there's not enough light? What if our plant doesn't have everything it needs? Again, engineering solutions to problems using coding and the items that come with the kit. So let's go back to Blockly. Okay, so you saw a little bit of Blockly, and by the way, the software that you saw running with the data, that's called SparkView. We also have Capstone software. If you go to Passco.com/downloads, you can get a trial version of either of these software versions. Blockly looks the same in both of them. But Capstone works only on the Windows and Mac, where SparkView works across devices. And in fact, SparkView is free in the App Store on your mobile devices. So you can just go there, go to your App Store and download the SparkView, SPARKVUE app, and start coding today with the sensors that are on your phone. And then later on, check out these kits if you want to do more with outputs. So going back to what you would see in the workspace area, so this big square here with the dots in it, we call that the workspace, and you drag blocks to the workspace. Now, if you are familiar with Scratch, you might have already worked with block coding. It's very similar. So you get blocks from the toolbox, and there are multiple categories of blocks, and I'll demonstrate using those in a minute. You might have seen me use the zoom in feature and centering feature as I was explaining code, and those tools are on the right side. There's also the trash can, so you can throw away code you didn't need, or maybe you just need to start fresh. You can just throw it in the trash can. And then there's this puzzle piece here, and in Capstone, it's a pink puzzle piece. But you go to the puzzle piece to toggle between the software and code. So right now we're looking at code in SparkView. And if I hit the puzzle piece, it toggles back to the data display. And if I hit the puzzle piece again, it goes to code. I'm going to start from the beginning though. How did I get this screen to begin with? Well, let's go to the very beginning. If you were to download SparkView, here's what you would see when you first open it. You would see a screen like this. Okay, now I'm going to show you how to connect the sensor, the control node from the beginning. Now you saw me connect it one way. You saw me hit the Bluetooth icon to get it connected, but this time I'm going to show you from the beginning how do we get that sensor connected. So first thing I want to do is turn on the control node, and there it is. It's searching for a Bluetooth signal now. It's flashing red. So I am going to go to sensor data. Here's another way to connect the control node. And then I select control node. So from the beginning, you're going to choose sensor data. You can turn on the control node and choose sensor data. And if you're thinking, I don't know where to begin, look at all this stuff. Well, here's in the middle, because I have the greenhouse kit, here's the greenhouse sensor with all those measurements I was talking about, temperature, humidity, brightness. And this is the water content. So I selected loam, which is what you would choose if you just have potting soil. But what if you have sand or clay? So these are adjustments for different soil types. So you can choose different measurements to display. Down here, it says control node onboard sensors. So these are the built-in sensors that are already built in to this control node, sensors that you don't have to buy because they're in here. So accelerometer in 3 different directions, and servo current, which would be out of these ports. And the servo is not used with the items that come with the greenhouse kit, but they are in the other 2 kits that I mentioned earlier. We don't need any of those measurements, so I'm just going to turn it off. And now you might think, okay, I want these measurements, but I just want to start coding because I don't know what I'm going to do these displays. And that's where I would go if I was a brand new user. I'd want to just start coding. So I'm going to go over here to where it says start coding. And this only shows up if you've connected the control node. And now here's what you see. Let me move this screen out of the way. Look at this. So when I click start coding, I see an animation on the screen. So here's what you see in SparkView. It gives you an idea of what to do. Oh, I grab this block. I drop it and it connects. Oh, I can change that number. I can type in there. And step 3, I can hit the start button. And the little picture shows musical notes coming out of the control node. Well, what it's trying to tell you is here's how to get code to work. Some real basic code. Number 1, start by clicking a repeat while do loop. Next, go to the true loop to make the code run forever. Repeat while true means run forever. It's a loop that never ends until you hit stop. Then I went to hardware to say I want to use the control node speaker to make a sound that's 740 hertz. Then there's a sleep. Now I'm gonna stop trying to keep up with this animation here, and I'm just gonna hit that code button because remember we can toggle to the workspace by hitting the code button. There's that same code you saw in the animation. So it was telling me, oh, I can drag blocks and I can change numbers. Let me change it to 500. And then there's a sleep function. Sleep means the code's going to stop executing for a minute. It's going to keep doing whatever it was already doing unless you tell it to stop. And then it's going to pause and then do the next thing and then do the next thing and then do the next thing. It goes in order. And if there's a sleep, then it just stops wherever it's at, whatever it's doing for the time that you set. And this says milliseconds. 250 milliseconds. Well, if you don't want to think about milliseconds, you can go to seconds, but be sure to change the value to second to the number when you change the unit because the magnitude is 1,000 between seconds and milliseconds. So if I hit start, you might not be able to hear it, so I'm going to get in closer. The control node is making sound. So it's making 3 different notes. And I'm going to hit stop. And I can play with this all day. I can take out parts of it and maybe only have 2 notes. This is a good place to start learning on how it works. What happens when I take away those blocks and throw them in the trash can? Let me hit start and see. I only hear 2 notes now. Well, what happens when I stop and I change the sleep to, let's say, 2 seconds? Now what happens? Oh, okay. So here's something to do when you're learning to code. Just change little bits and see what happens. See what is the result. Start, stop constantly. So that's a good coding tip for new coders. Now, something else that I want to show you, I'm going to go back to the presentation. So this is where a good place to start. But if you want to just jump in on the greenhouse, there's a place to do that as well. I'll get there. So here on these 3 block menu areas, here in the hardware section is where you'll be accessing sensor inputs and outputs. So if you're looking for the where am I going to get the temperature sensor from? Where do I get the reading from the humidity or soil moisture? That's in hardware. What if I want to use a sensor that I already have, like CO2? You can use pre-existing sensors that you have Pasco sensors, and you can incorporate them in the code with the greenhouse. Now, this one does not come with the greenhouse, but you can definitely use it if you want to study, for example, what is the rate of photosynthesis in this chamber when I make the lights only go blue or only go red? And I'll show you how you might be able to program that in a minute. So now the next box here, the code output, that's for text-based or numeric outputs, and I'll demonstrate a text-based output in a second. Then user input, you might want to create a list that's like a table you can type in, and you can use table data, use table user enter data to run in your program on the control node. So next, I also wanted to point out that we believe coding is for everyone. We're trying to remove as many barriers as we can. So you might, if you're familiar with SparkView, you know that you can change language from the main menu on the main screen here. When you change a language, you'll see 30 plus choices. You'll see here in the screenshot, I've converted to French, but this is Canada French. So you can also choose France French. So there are dialects and different languages available, and the codes translate, or the code and the blocks translate. Okay, so now I'm going to do a little bit of coding. We're going to look at turning outputs on and off, starting with the grow light. We're going to look at triggering outputs with sensor-based data input. And as a reminder, yes, you can use any Pasco sensor or onboard sensor for data input. What I mean by onboard sensor is if you go and get SparkView on your phone for free, you'll see that you've got onboard sensors already, like an accelerometer. Some phones have access to a light meter, etc. So if that's available, you can use it in code. And by the way, you're going to see me using emojis. Where did I get them? Go to emojiguide.org. I found that's the most reliable place to get emoji that you can put into your code that works across devices. So let's go back. I'm going back to SparkView, and I'm going to start. I just toggled back to the data display. Okay, so now I'm going to just start a new experiment. And so I'm going to act as if I just bought a brand new greenhouse system and I want to just play with it. What do I do? Okay, here's what I recommend. Start with the light. Everybody wants to start with the light, right? Because it's fun. So let's do that. So you would have connected the control node through sensor data. Mine is already connected, so I don't need to connect it again. It's already there, right, in my connected devices. I kind of don't, it doesn't matter what data display I'm going to use right now. I'm not really sure what data I want to see. I already saw what start coding does. Let me just pick a random template. Let's just do a digits and graph and see what happens. Well, because temperature was selected, it made a digit display and a graph display of temperature automatically for me, and that's how these came up here. But really what I'm interested in first is I want to see, I want to start coding, right? So I'm just going to go to the coding block now, and I want to get this light to behave differently, maybe based on temperature. Maybe I just want it on for a few seconds and then turn off. So let's see what we can do with this light. So like I said, you're going to find the outputs and sensors in hardware. I'm going to open the hardware blocks, and there's a whole bunch of choices here. There's my temperature sensor. That's not what I'm interested in yet. I will get there, but I want to use the grow light. So I see it down here, set the grow light. There's the block I want to get the grow light to work. So I pull out the grow light and I drag it. And it says, set the grow light for the control node, which is what I'm using. Port A, let me make sure it's plugged into port A, and it is plugged into port A, and I took the time to label my cables light. Okay, I labeled that this is a light cable so I don't get confused when I try to plug it in later. So yes, it's on port A. If I had it on port B, I could just pull it to drop down and choose B instead. But it's smart enough to know that my light is plugged into A. So it doesn't give me the choice of B because it recognizes it. Now, I can choose between red light and blue light, and the intensity can range from 0, which is off, to 10 in whole number values. So right now it's 50, it's set to 50% intensity red, 50% intensity blue. Let's see what that looks like. I'm going to hit start and don't blink. Look at the camera, look at the video, don't blink. Do you see it flash? Why didn't it stay on? Okay, well, it didn't stay on because it's doing exactly what the code says. It's like, okay, turn on red and blue, and that's all it says. Turn it on. Okay, code's done executing, so it's off. What if I want to keep it on? Well, I've got a few choices here. I can use one of those sleep functions. So where do I get sleep? Where it pauses the program and stops what it's doing for a little bit, I go to time. For time, I can pull out sleep. It defaults to milliseconds. I don't know about you, but I think more easily in seconds, even though programs, they run on milliseconds. But I get the choice of working in seconds. I wanted to stay on for 2 seconds. Let's see what that does. Hit start. 1, 2. Automatically off after 2 seconds. It's the program's doing what I said in the order that I said. What if I wanted to stay on until I hit stop? Well, in that case, let me move my move my video so you can see the trash can. I'm going to throw away the sleep block rather, and then I'm going to use a loop. And when I put this block, repeat while loop, what I want to do is keep repeating, turn on the light at these intensities forever, but I have to put a true in this empty puzzle piece here to make that happen. So repeat while true means keep going until I hit stop, run forever. So if I hit start, that light will stay on at the intensities that I've set until I hit stop. So I hit stop and now it's off. What if I want it to be completely red? That means I can change blue to 0 and leave red at 5, or I want it really red, I can change the intensity to 10. It's all red. So now you can already see, you might be thinking, oh, I could totally check out what happens to a plant when I put only red light or only blue light. Or as a seedling, I do different combinations of light versus a fully grown plant. What does that do to the growth rate of my plant? Does that affect how much flowers it produces, or whether it produces flowers at all? Or does it produce produce, like tomatoes or something? So you can already start seeing the possibilities here of programming your greenhouse to test questions about plants, living things, systems. You might not even want to put a plant in there. Maybe you're just interested in the physical effects of temperature and water and humidity within a closed system when you put heat in there from a light. All kinds of questions you can answer and explore. So that's one way. There's a couple different ways to get the light to turn on. You can use sleep blocks, you can use loops, or you can simply hit start and stop and watch the timer. So whatever level you're at, you can just build from there and move forward. Now, something else I want to show you is some pre-built code. I'm going to throw this code away. And in fact, actually, let me just go back to the main screen here. So here's my main SparkView screen. I'm going to open an existing file and show you an example of code that's already done. So the first code I'm going to bring up is called Grow Light Disco. So you can kind of predict what that might be doing. Let me move this out of the way. There. And I'm not going to save my changes. That's SparkView was asking if I wanted to save my changes. I have to make this a little bit smaller so you can keep an eye on what's happening there. Okay, now I'm going to hit start. There's my disco code. So I've got a disco light going. And there's an emoji as my output. How did I get picture in the output on SparkView? How did I do that? Let me show you how I did that. Okay, I'm going to, while it's running, I can look at the code while it's running. That's fine. But if I make any changes while it's running, it's not going to take effect until I hit stop and restart it. So how did I get this code going? Let's play that again. Now let's interpret the code. I have a variable here. Okay, so I got that variable from the variable menu. What I did is I said start at level 10 at the brightest. And when I end, I want to be at the lowest at 0. In my text output that I named hello, we're going to enter some stars. And then there's this repeat while true loop. And this is a little bit a step forward. If you're a beginner, you might be like, what is this? This looks complicated. It's another type of loop in a loop. And this would be, you're starting to get towards intermediate. Maybe now you're ready to do lists and you're ready to do counting steps in your loops. So there's plenty of room for growth and advancement in the blocks, but also in the types of things you can think of doing with the outputs in the greenhouse. So we are looking at a loop of intensities counting down from red to blue and shifting red to blue. That's why you see purple for a little bit, because at one point red is 5, blue is 5, so it's purplish. At one point it's red is 10 and blue is 0. So that's just how this code works. And you could modify it any way. to make it work for you. In fact, if you prefer rave and not disco, maybe you change it to 20 milliseconds and make it go faster. So it's a little bit quicker. Okay, so there's all kinds of modifications. And if you're learning, keep in mind, you remember Parsons problems, right? You can just take apart the code bits and put them out of order, mix it up, and give it to someone else and see if they can figure out what's the right order of things. How do I rebuild this and get it to work? What is the logical order of things? So that's another thing to do if you're trying to move from beginner to intermediate and you're stuck on how does the count work. Maybe trying this, maybe have someone mix it up for you, see if you can figure it out, and keep testing your code and plugging it back in just to see if you can understand the logic and the flow of what has to come before the next step can occur, because their code's always going to go in order that it's listed from top to bottom on the screen here. Okay, now how did I get the text output? That's going to be over here on code output. Let's say that I wanted to create a text output. Let me start over because this now looks really confusing with all these blocks, right? In fact, I'm going to just clear the entire screen. I can drag each piece individually to the trash, or since I'm on a Windows computer, I can just select and hit delete. That's a lot quicker to get rid of all of these off of my screen. I can also do something, troubleshooting function you can use is if you're in the middle of your code and you're not sure if a particular part of your code is working, you can click a block and right click over it and you can disable it. So it kind of turns it off without you having to modify your code, and it skips over it, doesn't look at it. So you can test and see, oh, is that the thing that was causing my error? You can also use duplicate if you want to make a copy of the same thing. You'll find that that's very useful when you're writing longer code. And you can make it turn back on by hitting enable block. And you can also select multiple blocks and delete them. Okay, so I said I was going to do a text output. So again, if you have just SparkView on your phone and you don't have sensors, you can try this. Let's say that I want to create a text output that says hi, because the other one says hello. So this one's going to say hi. I'm just naming it hi. Okay, so that might not make much sense. And then I hit OK. I said, make this text output, but nothing showed up, right? Here's why. You have to drag a block, any text block out, and then from the drop down, now you can choose the one you created. If you don't like that name, you can always rename it to something else. Something else. And say OK. So when we went back, when we're looking at the stars here, this was a text output called hello. Okay, so now in something else, other things is what's going to show up when I run my code. And if I run this code, all I'm going to get is something that says other things in the something else output. Let me run that. Oh, look, I'm on hello still. Well, I better switch my display to something else. How do I do that? Let me move this out of the way. Well, I am currently looking at the display called hello. If I click hello, that's how I change it. Notice how it says sensors up here, greenhouse sensors. Okay, it's not a greenhouse sensor, it's a text output. Okay, I've got control node sensors. It's not a control node sensors. I don't see my choice here, but that's because it's over here on the right side, user entered. Switch to the user entered, and there's my something else code. That's where it was. It was over here in user entered. A text output is in user entered. If it's a censored input, it's on sensors. If it's text, it's going to be over here in user entered. So there's my something else, there's my output. That's how we got the disco lights showing up on the text output with emoji. You can just copy and paste those to get those to work. Let me open up a different file to give you more ideas of how you can work with this greenhouse. So I'm going to open up this other one that uses emoji, kind of more of a cute way, I guess cute. So it's called Grow Light Emergency. And I'm going to wait for it to recognize my control node, move this out of the way. And so far you might be thinking, well, there's so much more you can do, right? You can do data, right? But I'm showing these simple codes just to help explain how these codes work. So you get the idea of what's going on here. You got different emergency vehicles. It's flashing red and blue, like you don't want to see in your rearview mirror. Let me explain how it's working. So here we now have a list. When you're ready and you're intermediate and you're ready to move on and learn more, now you can create lists. So we got a variable called emojis, creating lists. The text output is going to be the different emergency vehicles, and it says in a loop, go through this list. For every time that we run through for ambulance, I want to see red turn on and then blue turn on, and sleep in between those, and then go to the cop car, and then red on, blue on, and then go to the fire engine, and then red and blue, and then go to the siren, and then turn on red and blue, and then go to this other police car, and then red and blue, and then just keep going in that order. That's how this code works. So you can do lists, you can do iterations, you can go through each item in a list. Here's another code that I want to share with you. We're going to go a little bit more advanced here to another code now. Now we're going to move on to this other one called Grow Light Sun Model. So now this is more greenhousey, right? You're like, oh, finally, we're going to talk about more greenhouse stuff. Yeah. Well, one of the things that you want to do in your greenhouse is mimic nature, right? So we want to mimic the 24-hour cycle of the sun. Watch what this code does. We've got some text output, and now it's telling me what time of day it is, and it's showing the light intensity changing. And as the light intensity is changing, I'm getting a different message in my text box. And I've also thrown an emoji there. But I can do more. I can look at sensor data at the same time, right? I'm going to build a new display up here in the top left. Why don't we look at a couple things at a time? Why don't we look at the light intensity? Brightness. So you might be thinking, wow, you're going really fast through the SparkView stuff. That would be a whole other training on how to use SparkView. And I would recommend going to look for, getting started with SparkView to learn how I'm creating these displays, or you can just always rewatch the video. So I've got a brightness data now that I can see at the same time as my greenhouse performance. I can go and recreate that display where I had the text. Remember, the text is user entered, time of day. And maybe I want to look at a different measurement in the third box. Why don't I just look at temperature? There's my temperature. If I want to, I can add temperature on the graph. I have all the options that you normally see in SparkView. All the analysis tools that you have in SparkView are also available. I'm really just going to focus on the greenhouse part of it today. So now you can see the 24-hour cycle. This isn't obviously not 24 hours. It's like a sped through day. How did I do that? Here's a tip for coding. Now you're looking at this code thinking, whoa, look at that's a lot of code. Well, here's how this code works. So when you're ready for even more advanced, now we've got an array here. Here's a built array. And I used an array to time different light intensities. So the time on variable is how long the light will be on. This block is this for the intensity of the red light. This block next is the intensity of the blue light. And this block here is the message it'll say when I have red intensity of 1 and no blue. That's what it looks like at sunrise, right? When it's red sky. Early morning, now I'm increasing intensity of each color. High noon, I got full intensity. Early afternoon, I'm dropping back down. And finally, when it's sunset, it goes from red, only a little bit of red, to nothing. And I can make this run for 24 hours if I've got my numbers right and I make it all add up to 24 hours. Right now, I have it on milliseconds. So if you want to run a cycle that goes 24 hours at a time, I suggest you do the math and convert it to milliseconds so you can watch a whole day go by in just under 2 minutes. So that is a trick you can use for testing and speeding up your testing condition. Change from seconds to milliseconds if it's something like a 24-hour cycle. Okay, so now what else can we do? How do we get the pump and fan to work? Okay, well, let's look at some other sample code. I think this was the 24-hour sun code. How about watering the plants? Okay, so now let's look at a code that's specifically for watering plants. And you might be wondering, can we do it all at once? And yes, you can. I'll talk about that in a minute. Yes, you can get everything going at once. So this program, I'm going to switch to the zoom in on the dripper. This program will say, let me go to the code side. It's going to say when the water level is greater than 5, just say we're good with soil moisture. So 5% soil moisture, everything's fine. We don't need to add water. But if it's lower than 5, is lower than threshold, well, let's make the alarm go off and start watering. and turn on the pump and then sleep for a little bit, turn on the pump, sleep for a little bit, turn on the pump, sleep for a little bit, turn on the pump, sleep for a little bit. And right now it says port B. I'm going to quickly switch back. Port B has the power output on it, and the power output has two channels. Channel 1 has a fan currently plugged in, and channel 2 currently has the water pump plugged in. So because water pump is on channel 2, I better adjust my code, because the last time I ran this code, I had the pump on channel 1. So I wanted to point this out. This might be something that happens to you. If you're playing with the greenhouse, you've forgotten that you swapped your channels. While it does know which port the light is plugged in, it doesn't know which USB plug is which here on your power output. So you have to check and make sure you've got the right channel selected. Port B is right, but the channel is all channel 2 for my pump right now. That's just how I happened to arrange it today. Okay, so now one last thing. I think my water level is not good. So I want to point something out in SparkView software. Down here on the far left, I'm displaying, I chose to show the soil moisture as loam. Right now it's at 22%. 22% is really high. So I need to modify my code so I can always go to the display and see the preview of what the sensor reading is before I even hit start. It's 22%. So I'm going to modify my code to say, if my water level is greater than, let's say 23, that's just a little more than what it is now, then say everything's okay. But if it's less than, I'm just gonna say 22.9 because it's gonna round. If it's less than 22.9, start watering just so I can show you that it's gonna water. Okay, and I'm gonna switch my camera to the watering, and I'm going to go back to my code and hit start. Oh, it's saying it's watering because it's, oh, now it's 23. Well, it can't make up its mind, it's reading. So my output here, oh, look, it just went to 24 and went back down to 22. So it is turning on and then turning off. Why is it turning off? Again, we don't want the water to flood. We need that water time to percolate down into the soil and for the soil moisture sensor to recognize it. It keeps watering because as long as it's below 22.9, it thinks it's too dry because that's what I told the code to do. Oh, it just jumped up to 31 for a second. I think some water must have hit the side. That's why I did that. Now I'm going to hit stop. So once it goes past the threshold of 22.9, it'll stop watering and it'll say stable. Okay, so that's an example of using the watering system. Let me switch back to the full system. Here's another example. I'm going to now show some code with proportional control. So this is a pretty advanced concept here for coders. You can go from, like you saw, going from just turning something off and on, bang, bang control, off and on, all the way to proportional control. There's a huge range you can go here. Wherever you're at, there's a spot for you in your coding comfort level from beginner to advanced. We're gonna look at the code, and I said this was advanced, and look how minimal it looks, but that's because I've got functions in here. Okay, you can do functions and functions with input values that you can change easily by creating an input value. I've got this function collapse right now. I'm gonna expand. Yep, there's all the code. There it is. Here's how the proportional control works. You create a range of error above and below which you allow whatever value you're monitoring to go. So in this case, we're saying temperature. We're saying, well, we'll let the light stay on brightly as long as the temperature is within the range we think is acceptable. But as soon as it gets too hot, we want that light to actively start going down a little bit so that it gets cooler, but at the same time, we want to maximize the intensity without it getting too hot in there. And this is kind of how your cruise control works in your car, right? You want to maintain a specific speed. And if you have to go uphill, you got to put in more gas and it goes a little faster, but then it slows down because it starts going too fast and you're putting a little bit less gas. It's like trying to find its way around equilibrium around this value that you've set as the ideal. So we've set the ideal temperature here at 22.5. Let me quick check the value. Right now it's at 22.8. So I'm going to set it closer to the actual value, 22.8. Let's say our ideal temperature is 22.8, where it is right now. And let's see how this code works. So I'm going to hit start. It's ideal. So the brightness is staying pretty stable, but pretty soon it's going to get warm in there because that, again, this is energy. It's adding energy into the system. That is going to bump up the temperature a little bit. Let me move this out of the way so you can see better. Let's see what happens when the temperature gets too warm. Okay, you can see the fan turn on, see the feather moving? It's programmed to turn on the fan, but look, the temperature went up, brightness went down. And if that temperature is able to go back down again, the brightness can go back up. That's how this proportional control program will work. And I'm not sure if that's going to happen because I got a big studio light right above here and it's putting a lot of heat in already. So we'll see if I'll give it a few seconds to see if it gets cooler. And it looks like it's not going to cool down very quickly anyway. But it's trying to bring it, it's going to be bringing the brightness down as enough to just keep it within the error of margin, very close to the ideal temperature, just like your cruise control on your car with speed. So over time, look, the temperature went down, the fan turned off, the brightness went back up. For a second, it just got too hot though, and it instantly went back. And now you're seeing it, this equilibrium come, this fight between the temperature and the brightness, and it's going to eventually come to equilibrium and level out. And that's how proportional control works. Given time, you'll see it make a more smoother data. So I'm going to hit stop. And now, let's see if I have time. I don't think I have time. I don't have time to show you any more code from here, but what I will do is show what happens when you do connect a sensor like the CO2 sensor to SparkView and how to get it in your code. So I'm going to turn it on. I'm going back to my data display so I can get to the Bluetooth button, Bluetooth icon, and then I can connect the carbon dioxide sensor. And the way that I will work this sensor into the code is just by going back and into the hardware option. I see value of temperature. That's my sensor block. So if I pull one of those out and I pull the drop down, I should see there's my CO2 now. Now I have CO2 available. So that's how I get other sensors beyond what's in the greenhouse sensor, the temperature, humidity, light, and soil moisture. So that's one thing I wanted to show you. Okay, that's a lot of stuff to take in, but there's more. So what I want to show you next is these buttons up here. Now, this folder comes up. It's a Pasco code library. So what it is, if you know how to use functions, and when you get there, when you get to learn how to use functions, you can go and change it from PascoBot to Greenhouse, and then there's these pre-built functions in there. And that takes some pretty complex code, like that regulate temperature, this one. It's basically the code you just saw working. You'd need to do a little modification to get it to work for you, but there it is. Water plants, you saw some of that today, and model sunlight, that's a 24-hour cycle. So that's functions that are pre-built and available for you. If you want to share your code with someone, you can hit this button. This is the export button. By the way, the export and import, these two buttons, you send out code and you call it whatever you want. I'm going to call it Barbara's code or just Barbara. And then it says it's going to save as PCBX. I'm going to save it. So it shot out my code. Now I can share that code with somebody else so that when someone else comes along, I'm going to start a new experiment here, and they open up SparkView and they want to do some coding, or maybe I'm sharing my code with myself, they can create any display that they want just so that they can get to the Blockly icon, and they go in there and they got a blank slate, but they can import now any PCBX file. And this works in Capstone or SparkView. There's the code that I just exported, and I can import it in here. There's that code right there. So import export, that works on Windows, Mac, and Chromebooks on Chrome OS. This doesn't work on smartphones because the file systems are so different. But it does work on Chromebook, Windows, and Mac. Another thing I can do is I can hit this upload code button. If I do that, the code node just made a noise, control node just made a noise. And if I hit this play button, it starts running the code on here without needing SparkView. So if I close SparkView, oops, the code continues running. The code is still running, as you can see. And in fact, I can totally turn off my control node and then turn it back on. And if I tap it, it starts running that code again. That is running autonomously without SparkView. I don't even need a computer to make this run if I upload the code onto the control node. So that's a nice feature, especially on a greenhouse when you go on Christmas break or whatever, you're gone for 2 weeks and you can't keep your computer on that long, well, this will work for you. Okay, now I'm going to move that out of the way and we're going to wrap up. I want to talk about the activities. I said I would talk about the digital activities that come free. So I just went over this with the autonomous code execution and sharing. The free lab activities, all you have to do is go to Pascal.com and you can just type in search greenhouse and you can find your way to the free labs. Here they are. There are 5 and they're in the order of difficulty of beginner to expert or advanced rather. So you would start here with experiment 1, program a sunny day for plants. And if you are a teacher, you can create a free teacher account and you'll get the teacher guide, which has sample code. And as I showed you earlier, you can code the same thing multiple ways. So these are just suggestions. Here's a student version with plenty of pictures and sample code to copy while you're learning, and ideas for testing and ideas for doing extra fun activities after you learned each piece. So you starting here with variables and loops, and then finally ending up all the way back to the last one where you run the greenhouse system autonomously with automatic watering, automatic light, automatic 24-hour cycle. This one's with proportional control. So it gradually walks you through little by little, starting with the variable, then going to conditional statements here in the second lab, then going to functions here in the third lab, and then lists and arrays next, and finally putting it all together using imported code. So you can point your camera and go here. This is a YouTube channel that helps with how do I put all this stuff together? Like you might be putting the watering system together and be having questions. I would go here to this YouTube channel. Just scan this QR code to get there. You could also go just to within the software, go to the help in the software, and there's reference for all of the blocks and what they do there. So I went through most of these coding tips for coding success as we were going. You want to start with the plan though, like write out your ideas as a flow chart. Embrace pair programming, where the driver is the person who's writing the code, they're at the computer, they're using the mouse, and the navigator's there coming up with ideas and looking for troubleshooting, because working in pairs, it's like reading your own essay over and over. You sometimes don't see your own mistakes, and you want a little help, but then you want to switch roles. You want navigator and driver to swap positions every now and then, so everybody gets a chance to experience different ways of engaging. Code in small chunks, do one thing at a time, and then test. Use those text and graph displays and outputs to see that the results are what you think they are midway through. And like I showed you with the preview, always look and see where you're starting at so that when you're coding, you're using reasonable numbers for your conditions. Add sound alerts from the control node so you can hear sometimes when something is outside of a specification. Sleep blocks. I can't tell you how many times I got stuck and a sleep block fixed my problem. Sometimes you just need the code, give the code time to catch up, depending on what the process is. And finally, if you use, let's say you're reading the temperature 4 or 5 times in the code, you're going to want to create a variable for that. And if you go to the free lab activities, that explains how to do that. Other support, other places you can go for help, technical support, pascal.com/support. And here are some other videos and places you can go for help, not only with coding, but also with SparkView. Thanks for watching, everybody. I hope that you get coding, and happy Computer Science Week and happy coding.